Hello, I am Vaishnavi Shrivas and in this video we are going to understand critical section problem in operating system. So let's start. At first, before discussing critical section problem, let's see what is critical section is. So critical section is basically a segment of code of every processes. That means each process has a segment of code. Segment of code basically means the instructions or the tasks which the process has to perform. So that code contains the task or the instruction which the process wants to do by informing the system that yes, these are the tasks and this I want to perform. So before moving on to the critical section problem, let's see one point that each process has a segment of code. That means every process has their own critical sections. Means they have each process has their own instructions or tasks that they want to perform, and when one process is executing in its critical section, no other process can execute in its critical section. It means at a time only one process is executing in its critical section, which directly means that at a time only one process performs its task, and when it is using the CPU, no other process is allowed to use the CPU or execute its task or execute in its critical section. Now let's see what is critical section problem. So critical section problem is basically when there are two or more processes who tries to execute or who tries to access the same data or manipulate that data. So it creates problem when two or more process simultaneously they want to execute the same task. So basically the critical section problem is to design a protocol that the processes can use to cooperate. So every process should use this protocol so that this problem does not happen in the CPU, and every process can individually perform their task by timely and on their turn. So there are certain rules which a process should follow when executing in its critical section. First is each process must request permission to enter its critical section. It means whenever a process want to perform a task of its, then they must request permission. They must request for the permission from the CPU that can I perform this task, and if the CPU grant the request, then the process can execute their task, and if not, then they have to wait. It means if the CPU does not grant the permission, it means some other process is executing in its critical section. That's why CPU does not grant the permission to the process who is requesting. Second is the section of code implementing this request is entry section. So the entry section is the one who handles this request. A process want to request the CPU, so entry section contains the code which helps in regulating the process, granting and holding the permission to the processes. Third is the critical section is followed by an exit section. After a process performs its task and completed, it should exit and let the other processes do its task. So that is handled by the exit section. Last is the remaining code is the remainder section. After the exit section, there is a remainder section. If the process wants to perform any other task after executing in its critical section, or any other task is there by the CPU, then that code is contained in the remainder section. Now let's see the solution. Like whatever the solution to the critical section problem must contain these 3 points. First is mutual exclusion, second is progress, third is bounded waiting. What happens in mutual exclusion is whenever process is executing in its critical section, then no other process can be executing in their critical section. As I explained earlier, it means that no two processes can simultaneously execute in its critical section. No two processes can execute in its critical section at the same time. Second is progress. In progress, what happens if there is no process executing in its critical section, and some other process came and request for the permission from the CPU that I want to execute my code, then that are not then those processes only that are not executing in their remainder section can participate in the decision on which will enter its critical section next, and this selection is not postponed indefinitely, which means that only those processes which is not executing in its critical in its remainder section, means there is no process in the critical section and other process is granting the request. Now some other process should not also execute in the remainder section, then only other processes will grant, the CPU will grant the permission to the other process, and the other process can execute in its critical section. And if there is a process who is which is executing in the remainder section, then CPU will not grant the permission to other process who is requesting to execute its critical section, and the process have to wait, and this wait, the process should not wait indefinitely. After some time it should get the permission and allow to execute its task. Third is bounded waiting. There exists a limit on the number of time that other processes are allowed to enter their critical section after process has made a request to enter its critical section and before that request is granted. It means that the processes should not request again and again. There should be limit, like 3 or 4 times only every process can grant permission. It should not be like indefinitely the process is asking for the permission and it's not getting its chance. This should not happen. After asking for 2 or 3 times, the process should get its permission to execute in its critical section. So this rules, the solution to the critical section problem must follow these 3 points, and then only it will solve our critical section problem, otherwise no. I hope you all understood the topic. Thank you.